explanation, brief introduction about GeoModeler application on groundwater. The basic idea of doing analysis on GeoModeler is we somehow able to create a conceptual model very precisely, which is very near to the real geology. And this is where a GeoModeler help us to do that. Because most of the calculation, analytical calculation will be based on our model. So if we able to create a best model out of our data available in our hand, we able to estimate the accurate statistical calculation on GeoModel. So this is what we're trying to see today, and we'll see how easily we can integrate GeoModeler output with other softwares like Mudflow, FeeFlow. That is kind of interoperable between both the softwares. We can interchange the files between different platforms. That will help us to do different kind of operations in a quick basis. That will help for finding the accurate solutions for our modeling and the further objective. So the agenda will be, today's agenda will be discuss the validation approach for the rigorous groundwater assessment, how we proceed, how we validate our workflow using different techniques. Then create, sorry, there's some spelling mistake because I have created this PPT in very short interval of time. So I apologize for that. So how easily we can create a geological model using GeoModeler software. And then we try to establish relationship between the GeoModeler and other softwares like Mudflow, FeeFlow, from data interchange point of view. Well, we'll create different meshes, finite element meshes that can be directly integrated with FeeFlow. Then we'll use Seagull library in GeoModeler, which is available in GeoModeler, to export and control the various meshes that we can use as per we can use and customize as per our desire. We'll see some case study on the real data set, and then we'll discuss if there are any questions and clarification required at your end. Now let's first discuss the validation approach of the GeoModeler. The thing is, with the numerical modeling will be the part of groundwater workflow for achieving a quantitative approach of the groundwater resource assessment. This is an important thing to consider, which are choosing the model in full 3D environment, choosing to attribute your mass with physical properties which directly relate the geologic volume, and the location of the structures. Also, we choose to build a realistic geological model constrained by your geological observations that you have already. We believe that only a 3D incorporating realistic geology can deliver a reliable numerical model. And there are some techniques, platform available that we can use to build a realistic geological model and then export the geological information to a watertight mesh to provide direct mesh or the direct mesh support. GeoModeler provide the best practice by building a realistic geological model based on your available data and provide the ready mesh that you may require for numerical simulations. So we are different objectives. First, we create a geological model, and to understand by understanding your data, what data that you have available, And what's hydrostratigraphic unit or of your cast area. We verify those data and build a geological model, structural model that honor your all primary observation observations, sorry, and also include a fault system into it. The conceptual model that we created uh, initially will provide the characterization of the aquifer. We can view the false areas in 3D, the compartments and connectivity within the faults. We understand the flow system, including pathway, flow direction, and springs. Also, we can calculate the aquifer volumetrics and estimate the reserves of that area, the particular volume. Then the final model we can export in different finite element mesh for our numerical simulation in FIFO. So there are reasons to choose the GeoModeler software because GeoModeler is providing a flexible way to create a 3D geological model. It can constrain your maximum available data that you have, irrespective to any format. And if you have the space geological data, that is completely okay with it. So in GeoModeler, variety of inputs we can use in order to create a constrained geological model, more accurate geological model. And data could be anything related, including your surface geological map, outcrop map, drilling data, any cross-sectional image, geological image, or any interpretational understanding from seismic or any electromagnetic interpretations. So those all information we can put in together and create a geological model. Maximum, if we the high number of observation we use, the more accuracy in the modeling we achieve. So in order to do that, we can easily edit and recompute our model that that is under process of modeling whenever the new data is available for the study. This is allow us to interactively update our model throughout the time. Since GeoModeler understands the data, stratigraphy, and the orientation properly, they it, uh, it, it will use all this information information and try to calculate the maximums calculate the like the interpolated surface based on co-kriging interpolation, which is the best geostatistical interpolation algorithm. Co-kriging, that means we applying kriging method in three direction, not in two direction. So the rule-based modeling are able to provide us the provide us the maximum smooth surface, maximum optimized geological surface based on data available to you. By honoring your rest of the information like geological stratigraphy, cross correlation, on lab, off lab, so that you're able to achieve a model which is very realistic in terms of geological stratigraphy rules and uh, uh, and the relationship that we built using the geological stratigraphy that help us to understand the complexity. We incorporate the complexity in your model. Then in GeoModeler, we have already discussed this, that we also use some additional data like gravity magnetic to further improve our uh, initial model with the help of geophysics. Geophysics will help us uh, to optimize our model and optimize the properties of our physical properties of our model. That will uh, uh, help us to estimate the accurate geological structures as well as the properties of the geology that you have created. Once we satisfy with the conceptual model, we move further for further calculation on integration on the free flow. So as I said, the co-kriging interpolation that is used in GeoModeler for interpolating the surface and how it's working in GeoModeler. As I already have demonstrated this and explained this concept in a first day of the session, that GeoModeler, the basic principle of GeoModeler to interpolate uh, and the potential isopotential surface based on the points information that you are providing and the orientation data that help us guide uh, the shape of that particular isopotential line. This is how we able to achieve a surface based on both the information, principal information. The geomodel allows us to uh, like calculate various element mesh, various meshes, either it is point mesh, finite element mesh, triangulated mesh, tetrahedral mesh. Once we able to create the geological structure, and we can use all these options, whatever the option we like for our further analysis and integration or export the various different platforms for our study. So this is the example from one of the area the cast topographies. There we have used several data set to create this model. Most of the data are the geological maps in the appropriate scale. And also we have used 3 cross sections, which could be the geological cross sections, and 173 boreholes. That is too huge. Based on the surface geological map, we have marked several formations, ecology, and set and fix this all lithology based on a sequence stratigraphy. There are some fault network also has been digitized. There are several faults information that has been incorporated properly. So in here, based on the information from surface as well as drill hole data, we can convert, we can easily create a 3D geological model. So this is the well data that we have utilized in 173. Only 47 wells has been considered. The cross-sectional image, this image can go along the appropriate location, geolocated line. We project this map on particular line along the depth, and then we can digitize the horizons based on the layers available on the map. We can see and take a pencil and digitize this layer and convert it into the 3D model. The final model that is created using after the computation is look like just as you see in the below image. So based on previous study of this area, there are several layers are available comprising 5 hydrogeological units, which is available in this table. Some are the aquifer, some are the equitard. So these are information we have to consider when we do the modeling, so that when we do the like mathematical calculations on free flow, we have to consider the appropriate layer into our for um, analysis of the water conductivity and other aspects of uh, that we consider. So after reviewing the characterization of each and every formations, we can mark those formations properly and convert it and create a geological model. You can see that we have created this model, which is quite complex, that incorporated the fault information and the layers informations. So all the components has been displayed one by one, and the field metal in the final stage that can be displayed. The fence diagram help us to understand the water flow direction. Just like this is a kind of spatial interpretation, qualitative interpretation of the flow direction. This can be, we can export this image and try to understand where the flow direction is happening from on what region. So this is what we do in terms of geomodel application, and then after completing all this exercise, once we're happy with our conceptual model, that by integrating all the observations which is available to us, we then can export various finite element mesh that can be supported directly or indirectly in free flow environment. I'll show you different methods to couple geomodeler with the groundwater applications such as free flow, mud flow, how we can export various finite element mesh either in unstructured or field centroid, and show you how we can easily integrate it in free flow environment. And also we'll see a Seagull applications and how we can customize our mesh and mesh parameter to export the desired mesh as per our expectation. A few examples from coupling geomodeler and the free flow. This is hydrological model layered finite element mesh. The steady state and transient flow modeling. It has been already been considered for utility. This is another example for a direct export finite element mesh with the attribute in along with the attribute that can directly drag and drop in free flow, and we can highlight the attribute property by just clicking one option here. Full unstructured mesh export from GeoModeler. This option is available using Seagull library. And this Seagull library provide extra user control for customizing the mesh. The output will be the highly watertight and manifold that contains the high level of contains the fine structures intact into the finite element mesh that can reduce the computational error by 30%. Let's move to the software demonstration. But before I go, if you have any question regarding the presentation, or if you have anything in your mind regarding the software, then let me know.
I was not here for the beginning GeoModeler. So like in GeoModeler, can you already there give the like hydraulic conductivity for a layer so that when you export a mesh to FeeFlow, does it already go there, or do you then have to like pick your areas in FeeFlow for parameter assignation?
I I I don't see any option of exporting
Okay.
finite
Yeah.
mass having like hydraulic
Okay.
conductivity into it as a property.
So there's no like parameter
But
assignation already in GeoModeler.
sorry,
So there's like no parameter
no,
assignation already in
no. We
no.
cannot
Yeah,
integrate
yeah,
any
sure. Okay.
properties into it.
All right.
Just we can
Thank you.
export the structures. Yeah.
Yeah.
Okay.
Okay.
Let me just open GeoModel software then see. Are you able to see the screen, GeoModel screen? Yeah. So the first thing I'll show you the extracting the surface top from the geological model, existing geological model, which already have been prepared, because we already have done several sessions on how to create geological model using various inputs, including geological maps, drill hole data, surface geological observations. So we're not going to spend time on it. Just I'll show you how we export the surfaces so that you can directly use those information as an input for creating finite element mesh in your free flow or mud flow environment. This is a basic model, one of the basic model. You can see this surface topography. We have incorporated surface topography into this model, and we have 4 layers of lithology. And the layer D and layer C, we can mask it and see how the structures are look like layer by layer. To export the surface top uh, uh, is the top of a particular lithology. So if in order to export the surface top, we have to convert this uh, geological model into discrete form. To convert this whole model in a small cell size so that we can export uh, the centroid location in XYZ that can be used in that can be used in any other software for creating surfaces. To do that, I'll just go here and right click over it, and then we'll hit this button here, option here, to create 3D uh, uh, discrete model on a variable cell size. Let's just hit this button. The cells of this discrete is 2 cores. If you would like to, like, let's make it slightly finer so that we not going to take 400 as of now. Great, maybe 150. Hit OK. Let's look slightly better. So this is the discrete form of the model that we have created. If you like to display it layer by layer, you can go here, click color and clip option, and we can use this uh, uh, customization area to clip the visualization of the formation, and we can set the numbering of the lithology to highlight only those lithology that we like to visualize. But how we understand that what formation is indicated by what number? To understand this, we can go here, geology and stratigraphic pile, and we hit here, click model pile. We'll see that the number of the lithology, the formation, is given by below is 1, and if you go above, it's going to 2 and 3 and 4. So if you'd like to display the lithology between 1 and 2, only two formation will be displayed. If you're masking it from 1 to 3, 3 formation will be displayed. But this is how we can play around for the visualization. I'm just going to be, make this default as it was earlier. So to export the surface cell of the bottom layer, suppose we would like to export the top of this volume A, like the bottom one, the orange lithology. We'd like to export the surface top of the A formation. To do that, we can right click over here and go surface cell export. This will provide us the option to export the surface top in a various file formats, either templated surface or CSV top. It just, in this case, we're just choosing the ASCII file to restore the surface top information. It will set the output file location. Surface top. Bottom layer CSV, this is fine. One thing we need to like have to careful about to put the value of the formation that whose surface top we would like to export. In this case, the bottom formation has a value 1. So we'll set this to 1 and we'll click OK. I guess we already have exported file. I show that. Where it is? Here, surface top. This is the bottom layer that we have exported. If I open this file, the location of each and every cell, center of the cell, as stored is in X, Y, and Z information. One is actually representing the formation name, which is one. Let's just import this file again in GeoModeler and see what this surface is actually denoting. To import this file, the surface dot file, we'll go here, right click over it, and then go to import, and select this 2D theory observations. We'll bring this file into GeoModeler, and we'll go here step by step by checking all the information properly. This is what GeoModeler is looking for. So we have to assign these columns with the data set, which is available in this table, so that all the information are linked with the appropriate one. Click OK. So this is the bottom layer values. I'll display this in 3D view. I don't know if you're able to see it. Yeah, here. So this is the surface top of the bottom layer. So this CSV file can be used in anywhere to create the layered mass, either in vFlow or mudflow environment, for creating the same geological layer. One thing we need to this is like providing us the accurately create the surfaces based on implicit geological modeling and based on the data available to you. And after that, the exporting information from here will lead you to create a accurate finite element massing for your mathematical simulations. Just going to export one more file. Layer 2. And this time we'll put the value 2, that is the information just above this structure. This is the surface top that is highly correlated. And then we're just going to export the formation number 2. Or maybe if you like, you can export the formation number 4 or 3. Just going to export the formation number 2 this time. I guess it is done. And I'm going to import this again, GeoModeler, to visualize. Next. I'm going to sync all this fill value with the appropriate area. And here, this one as the layer 2 values. There it is. So we have all the geolocated information on the surface that can be used. Similarly, we can export all layers and make it ready for modeling. So this is the one procedure for exporting layer by layer information, and then use all this information to import in water to import in people environment. Let's move to the next tutorial where we'll use our model Mansfield syncline to export as a field uh, as a like um, okay. Let me just open this again. Yes, all the files has gone and disturbed. Let me open this Tunisia project to complete the session. What has happened to all the models? Why these are look like this? I'm just really surprised. Yeah, just opening a fresh project and let's see how to proceed with this. Okay, so this is our model. A highly rendered, high quality model that has like very like so many details into it. Like there's a huge type of structure going along, and there are several structures which can be visualized here. Walls, lines. So let's see how we can directly export this finite element mesh and can integrate this into free flow environment. So to do that, we just go here, export to 3D model, and then we'll go to here, the model. This allows us to export our model in a various file formats that includes the file supported in FreeFlow. Output to Mansfield model .fem. And we'll sit here, the FreeFlow, click here to export the FreeFlow supported model. And when we hit OK, it will start calculating the mesh that can be useful to directly drag and drop to the FreeFlow environment with all the properties into it. This may take time. I'm just opening the FreeFlow case it get created. Okay. So this is the file that has been created uh, from GeoMod directly. You see that there are same details that has been used to export. It's very nice work, triangulation work on this model. And since we already have uh, properties, rock types, but double click over here, it will display the structures as well, the geological units, and the details of geological structures into it. See here. And there are several structures are well preserved in this model. We are zooming out, that's why zooming in, that's why we this is actually a display problem. But the lithology is quite well preserved in this triangulation. And also you can visualize the deep and azimuth. Double clicking on it. Okay, so this is the thing people can create. The fourth and the important one is to export this file into various finite element mesh using Sega library. To do that, we can open the Sega library either from the search window here, sorry, from here, build a 3D geological mesh product. So this wizard help us to allow us to create various finite element mesh and various uh, customized mesh that includes the various component to it, where we can consider either compute the triple lines stored in our data set in our model, or we either can use no triple line into consideration, so that it can only give us the default set of structures. I'm just going to use the default set as of now, but if you want, you can use this parameter to customize the spacing of the points and precision and the biasness of the thin body into different direction, and also the file type VTK and the locations where you're gonna save this project. All the components in the lithology can be visualized or will be exported as a finite element mesh. You can change this parameter based on your desire to get a proper customization on the maximum facet angle and the facet radius, ball radius for one of the triangulations. For this kind of customization you can do. You can either get access of these parameters as well, silver bond, by clicking here the options to allow us to get a proper um, uh, uh, refinement, bond refinement for your model. Click next. This section can help us to set the different type of formats that you like to export. You can export multiple formats in a single operation by adding the volume and set uh, the file type from the drop-down menu over here. Similarly, you can export other items as well as per your requirement. And then you can last choose this task that is going to execute here. Once I click finish, we will be able to see the mess that has been generated. In the console, you can see the progress of the operation. Once this finish, we're able to see a folder that has been generated in between. And there is a geomod file, which is a super mess that can be directly taken into vFlow. And also the VTU format. It's a it's kind of triangulated format that can be used in GeoModeler. Plus other VTP and DAT formats can be displayed. I'll show you how this can be visualized in GeoModeler again. I'll go here, import the triangulations. I'll open the VTU, sorry. And this will open up the various fields that is available in this mesh. This is the central area, like of the mesh, central point of the mesh. All the meshes can be displayed here. Similarly, the potential of that area. All other center points. We can also import triangulation of VTV that stores polygons false file. Then we can simply use this all exported format to vFlow environment. I'll show you that. vFlows. Okay, this is the version I like to use. We're gonna create a new model from fully unstructured 3D mesh. Then click next. We'll use the super mesh import from map. We have calculated the super mesh from GeoModeler as single export. So we're going to use that. Here we can import that mesh from sorry. Go to the GeoModeler project, super mesh, export, mesh field, export mesh. And here's a dot gmod file, which is a kind of can directly be imported and FeedFlow. You can also import the constraint date file and the region state file. I think the FeedFlow, the ones FeedFlow users are familiar with these files. To use this constraint file that holds some property information. Okay. So this one as a supermesh. See that it contains the, I don't know, various information. So this is the Seagull export option for calculating the various meshes. We can also export different formats that includes shapefiles and intersections on semi-grids that can be used to facilitate your your final modeling program in other software environment. I'm going to just going to show you that. We just open this other project over here. Build Centroid. So here we can export a model and let me just send the output file. Open it. Right. Export the interfaces and box it, ISO patches. Then I click OK. It's installed. Same here. Files. You see that we have estimated layer interface in ASCII grid, and also kind of interface as well as ISO patch. ISO patch is actually extra information from thickness of the top and the bottom of formation. You can also export the shapefile if you like to export this. Shapefile could be in any other format like tserv. It's all about surfaces, triangulated surfaces that can be help us to use any particular component to be visualized. Build. Illness. Okay, there's one thing is left, which I think I need to take a look first. There could be some problem with the step. I have to go and resolve it, and I'll show you how we can demo that during our session. So as of now, there's a different way I have demonstrated to integrate the flow, free flow and the geomodeler by exporting various finite element mesh, either a triangulated mesh or fill centroid mesh, unstructured mesh, super mesh. If you like any other way, or do you have any challenge to integrate your data into P-flow, let me know. I'll show you how we can do that easily, or any structure we can incorporate in your modeling environment. I would like to take a break for 15 minutes, and probably we will back again to discuss the remaining topics. Is that okay?
Sounds good.
Okay, perfect.
We can't hear you. You're muted.
Oh, sorry. Sorry, Vella.
Thank you.
Okay, we need to restart again. Yeah, so I'm gonna launch the feed flow. So this is the only topic left where we see how we fill the unstructured finite element mesh with the layer property. We'll use GeoModeler to fill the centroid with the property information into it. In this case, geological property. So to do that, we'll open the unstructured finite element mesh, and then we'll export this mesh as a text file that contains the coordinate of that centroid. To do that, we first have to create elemental distribution, which will be renamed to the geology. And then we'll export this data of all element as a centroid. I'm going to use a phrase folder for this. This is my folder. And we can export centroid as a dat file, .dat file. I'll click save. This will exporting it. Should the export map be able to convert it? No, we'll first use the geomodeler to fill the centroid, then we'll export into the fee flow, import the fee flow again. So we click no at this time. Now let's open the geomodeler to fill that centroid. I'm going to open the tutorial A, the project A. That model is already created into it. And this is the model that has been made in GeoModeler. We'll export a 3D model as a fee flow centroid. To fill this fee flow centroid, we'll use this export centroid dat file to fill with the properties, with the geological property. We'll click open. This operation will create 2 additional documents in a text format. This is the one. Export centroid field, which has already filled with geological information. The first thing, before we import back into the fee flow, this file has to be converted into the DAT format. DAT file. Then we'll back to the fee flow for the analysis. Before add any map, we should check that the other maps, there are no maps are available in this sections, in this map sections. Then we'll add this map, and we'll add this stat file into this map to be used in the for the visualization. So this ASCII file will be stored as a default here. We'll use this one and the edit parameter. It's not yet open. I think it's already in, okay, it's under process. Okay, so once the file is loaded, it will ask to set the coordinate of this mesh. We'll set X, Y, and Z centroid, center of the mesh, and click OK. Here. Okay. Then the next thing would be to link the parameter of this file with the geomodel with the fee flow parameter. For that, we'll use this option link parameter. Here, the centroid that we have exported contains the geological information in this, and this has to be set with user-defined geology that we have created. Right? And I'll hit the link here. It will set the relationship. Also, we have to supply the layer selection with the element number. The element of the mesh should be linked with the element containing the the fill centroid. And the last thing to set is to set the link selection should be set to the file name which has been imported. We'll apply no sorting method to do that. I'll click OK. Up to this stage, I think it's fine. Again, we'll go back to the default. and we'll check the edit property option. You panel property where this is. I think this after this stage, this is fine. Edit here, this one. Map property. To classify all the geology which we just linked, we need to go here and we have to select the geological information and the color palette which will be used for categorize the lithological component. In this case, we're using the mineral mineral palette. We'll use to classify. Here's the numbering that is stored in our file and the relevant color information of the lithology. Here, we can classify the attribute which is available in our dataset, field centroid file. We can either choose manually the attribute geology and to categorize the elements and the colors, we select any one color palette and then hit classify. Able to see the color of the formations which is stored in our file. Then we'll hit OK. Classification is done. There's one more thing we can do here. We can select enable this option throw 3D data so that can be displayed properly. The elements are displayed in the 3D view properly. Then the things we can set, other thing we can set the symbols of the geology from here, markers symbols from here. I'm going to set all the symbols to the square. Select one by one each. And then I'll update this information. When this done, we can now display the color of the lithology by double clicking on the default option here. You see the old geological patterns are visible now in a color format. And these are the colors of lithology. Going to put the images side by side so that you will to compare the geological angles. This is what the shape is. Here in the formation, you got the physiological field. visualize visualize the stratigraphic pile and the current model, you'll see the number of the lithology which is available here in this section. There it is. This section over here, you also see the number of geological sections. One is not available because the bottom of the layer will automatically fill without providing any information. So this is it. This is how we can field geological information in the unstructured layered mess. Further can use for the mathematical calculation. I hope this is helpful, and let me know if you require any further information regarding the workflow, and if any confusion regarding any of the stage, the geo model. I'll be happy to answer that. Thank you so much. Have a nice day.